Airplane Flying Handbook 11.3 Night Operations. Let's embark on a safe and organized flight by giving some serious thought to the pilot equipments where this journey begins. Pilot equipment. Pre-flight preparation is a critical aspect of ensuring a safe and organized flight. Pilots should carefully consider the personal equipment needed during the flight and have it readily available. This includes a flashlight, aeronautical charts, pertinent flight data, and a flight deck checklist containing procedures for various phases of the flight. Before starting engines. Before takeoff. Cruise. Before landing. After landing. Stopping engines. Emergencies. A reliable flashlight is recommended on all-night flights. It should be capable of producing both white and red light. The white light is used for pre-flight inspections, the red light for flight deck operations, and dim white light for chart reading. Pilots should ensure the flashlight is easily located and carry spare batteries. For night cross-country flights, aeronautical charts are essential. Pilots should have the relevant charts for the entire route, including adjacent charts if the course is near the chart's edge. Having charts organized and within easy reach contributes to a well-prepared flight. Additionally, pilots may use electronic flight bags for displaying charts. However, the brightness of the electronic flight bag's screen should be adjusted to avoid impairing night vision. Some pilots prefer using two flashlights, one with white light for pre-flight and another, like a pen light, with red light for in-flight use, especially to avoid color distortion on charts. Airplane equipment and lighting. 14 Code of Federal Regulations Part 91, Section 91.205, c. specifies the basic minimum airplane equipment that is required for visual flight rules flight at night. This equipment includes basic instruments, lights, electrical energy source, and spare fuses if applicable. The standard instruments required by 14 Code of Federal Regulations Part 91, Section 91.205, d. for IFR flight are valuable assets for aircraft control at night. 14 Code of Federal Regulations Part 91, Section 91.205, c. 3, specifies that during VFR flight at night, operating aircraft are required to have an approved anti-collision light system, which can include a flashing or rotating beacon and position lights. However, 14 Code of Federal Regulations Part 91, Section 91.209, b. gives the pilot in command leeway to turn off the anti-collision lights in the interest of safety. Airplane position lights are arranged similar to those of boats and ships. A red light is positioned on the left wingtip, a green light on the right wingtip, and a white light on the tail. This arrangement provides a means to determine the general direction of movement of other airplanes in flight. If both a red and green light of another aircraft are observed, and the red light is on the left and the green to the right, the airplane is flying the same direction. Care must be taken to maintain clearance. If red were on the right and green to the left, the airplane could be on a collision course. Landing lights are not only useful for taxi, takeoffs, and landings but also provide a means by which airplanes can be seen at night by other pilots. Pilots are encouraged to turn on their landing lights when operating within 10 miles of an airport and below 10,000 feet. Operation with landing lights on applies to both day and night or in conditions of reduced visibility. This should also be done in areas where flocks of birds may be expected. Although turning on aircraft lights supports the see and be seen concept, pilots should continue to keep a sharp lookout for other aircraft. Aircraft lights may blend in with the stars or the lights of the cities at night and go unnoticed unless a conscious effort is made to distinguish them from other lights. Airport and navigation lighting aids. Aeronautical lights are designed and installed in a variety of colors and configurations, each having its own purpose. Although some lights are used only during low ceiling and visibility conditions, this discussion includes only the lights that are fundamental to visual flight rules night operation. It is recommended that prior to a night flight, and particularly a cross-country night flight, that a check of the availability and status of lighting systems at the destination airport is made. This information can be found on aeronautical charts and in the chart supplements. The status of each facility can be determined by reviewing pertinent notices to airmen. Most airports have rotating beacons. The beacon rotates at a constant speed, thus producing a series of light flashes at regular intervals. These flashes may consist of a white flash and one or two different colors that are used to identify various types of landing areas. Lighted civilian land airports, alternating white and green lights. Lighted civilian water airports, alternating white and yellow lights. Lighted military airports, alternating white and green lights but are differentiated from civil airports by dual-peaked, Too quick, white flashes, then green. Beacons producing red flashes indicate obstructions or areas considered hazardous to aerial navigation. Steady burning red lights are used to mark obstructions on or near airports and sometimes to supplement flashing lights on en route obstructions. High-intensity, flashing white lights are used to mark some supporting structures of overhead transmission lines that stretch across rivers, chasms, and gorges. These high-intensity lights are also used to identify tall structures, such as chimneys and towers. As a result of technological advancements, runway lighting systems have become quite sophisticated to accommodate takeoffs and landings in various weather conditions. However, if flying is limited to visual flight rules only, it is important to be familiar with the basic lighting of runways and taxiways. The basic runway lighting system consists of two straight parallel lines of runway edge lights defining the lateral limits of the runway. These lights are aviation white, although aviation yellow may be substituted for a distance of 2,000 feet from the far end of the runway to indicate a caution zone. At some airports, the intensity of the runway edge lights can be activated and adjusted by radio control. The control system consists of a 3-step control responsive to 7, 5, and/or 3 microphone clicks. This 3-step control turns on lighting facilities capable of either 3-step, 2-step, or 1-step operation. The 3-step and 2-step lighting facilities can be altered in intensity, while the 1-step cannot. All lighting is illuminated for a period of 15 minutes from the most recent time of activation and may not be extinguished prior to the end of the 15-minute period. Suggested use is to always initially key the mic 7 times. This assures that all controlled lights are turned on to the maximum available intensity. If desired, adjustment can then be made, where the capability is provided, to a lower intensity by keying 5 and/or 3 times. Due to the close proximity of airports using the same frequency, radio-controlled lighting receivers may be set at low sensitivity, requiring the aircraft to be relatively close to activate the system. Consequently, even when lights are on, the pilot should always key the mic as directed when overflying an airport of intended landing or just prior to entering the final segment of an approach. This assures the aircraft is close enough to activate the system and a full 15-minute lighting duration is available. Training for night flight. Learning to fly safely at night takes time and experience. Pilots should practice maneuvers at night, including straight and level flight, climbs and descents, level turns, climbing and descending turns, and steep turns. Practicing recovery from unusual attitudes should only be done with a flight instructor. Pilots may practice these maneuvers with all the flight deck lights turned off, as well as on. This blackout training simulates an electrical or instrument light failure. Pilots should also use the navigation equipment and local navigational aids during the training. In spite of fewer references or checkpoints, night cross-country flights do not present particular problems if pre-planning is adequate. Just as during the day, the pilot continuously monitors position, time estimates, fuel consumed, and uses navigational aids, if available, to assist in monitoring en route progress. Preparation and pre-flight. Night flying requires that pilots are aware of and operate within their abilities and limitations. Although careful planning for any flight is essential, night flying demands more attention to the details of pre-flight preparation and planning. Preparation for a night flight includes a thorough review of available weather reports and forecasts, with particular attention given to temperature, dew point spread. A narrow temperature, dew point spread may indicate the possibility of fog. Emphasis should also be placed on wind direction and speed, as its effect on the airplane cannot be as easily detected at night as during the day. On night cross-country flights, pilots should select and use appropriate aeronautical charts, including the appropriate adjacent charts. Course lines should be drawn in black to be more distinguishable in low light conditions. Rotating beacons at airports, lighted obstructions, lights of cities or towns, and lights from major highway traffic all provide excellent visual checkpoints. If using a global positioning system, GPS, for navigation, the pilot should ensure that it works properly. All necessary waypoints should be loaded before the flight, and the database should be checked for accuracy prior to taking off and again once in flight. The use of radio navigation aids and communication facilities adds significantly to the safety and efficiency of night flying. Check all personal equipment prior to flight to ensure proper functioning and operation. All airplane lights should be checked for operation by turning them on momentarily during the pre-flight inspection. Position lights can be checked for loose connections by tapping the light fixture. If the lights blink while being tapped, determine the cause prior to flight. Parking ramps should be checked with a flashlight before entering the airplane. During the day, it is quite easy to see stepladders, chuck holes, wheel chocks, and other obstructions, but at night, it is more difficult, and a check of the area can prevent taxiing mishaps. Starting, taxiing, and run-up. Starting, taxiing, and run-up are essential phases of flight that demand careful attention and adherence to procedures. Starting the aircraft involves a thorough pre-flight inspection, ensuring the engine oil level is adequate, and checking for any visible damage. In the cockpit, secure loose items, set the brakes, and follow the aircraft's checklist for engine start procedures. During engine start, clear the area, announce intentions on the radio, if applicable, and monitor for abnormal indications. Conduct checks on engine instruments and verify the proper functioning of avionics and communication equipment. Taxiing follows the starting phase, requiring the release of brakes and controlled movement on the ground. Utilize the aircraft's steering mechanism and apply brakes as needed for speed control. Maintain clear communication with ground control and adhere to taxiway signs and markings to prevent runway incursions. The run-up phase involves selecting a designated area clear of other traffic. Apply brakes to keep the aircraft stationary during the run-up procedure. Follow the aircraft's checklist for the run-up, checking engine performance, magnetos, flight controls, and instruments. Announce intentions on the radio before taxiing onto the runway. These procedures are crucial for safe and efficient ground operations, and pilots should refer to the specific aircraft's checklist and manufacturer guidelines for detailed instructions. Additionally, adherence to air traffic control instructions is paramount during taxiing. Takeoff and climb. The most noticeable difference between daylight and nighttime flying is the limited availability of outside visual references at night. Therefore, flight instruments should be used to a greater degree in controlling the airplane. This is particularly true on night takeoffs and climbs. The pilot should adjust the flight deck lights to a minimum brightness that will allow for reading the instruments and switches but not hinder outside vision. Dimming the lights also eliminates reflections on the windshield and windows. After ensuring that the final approach and runway are clear of other air traffic, or when cleared for takeoff by the air traffic controller, the pilot turns the landing and taxi lights on and lines the airplane up with the centerline of the runway. If the runway does not have centerline lighting, the painted centerline and the distance from the runway edge lights on each side indicate the center. The heading indicator should be noted and correspond or set to the known runway direction. To begin the takeoff, the pilot releases the brakes and advances the throttle smoothly to maximum allowable power. As it accelerates, the airplane should be kept moving straight ahead between and parallel to the runway edge lights. The procedure for night takeoffs is the same as for normal daytime takeoffs, except that many of the runway visual cues are not available. The pilot should check the flight instruments frequently during the takeoff to ensure proper airspeed, attitude, and heading. As the airspeed reaches the normal lift-off speed, the pilot adjusts the pitch attitude to establish a normal climb by referring to both outside visual references, such as lights, and to the flight instruments. See the figure. Without visual references ahead, inexperienced pilots may relax right rudder pressure after takeoff and veer off to the left. After becoming airborne, the darkness of night often makes it difficult to note whether the airplane is getting closer to or farther from the surface. The attitude indicator, vertical speed indicator, and altimeter should all indicate a positive climb. It is also important to ensure the airspeed is at best climb speed. The pilot makes necessary pitch and bank adjustments by referencing the attitude and heading indicators. It is recommended that turns not be made until reaching a safe maneuvering altitude. Although the use of the landing lights is helpful during the takeoff, they become ineffective after the airplane has climbed to an altitude where the light beam no longer extends to the surface. The light can cause distortion when it is reflected by haze, smoke, or clouds that might exist in the climb. Therefore, when the landing light is used for the takeoff, it should be turned off after the climb is well established, provided it is not being used for collision avoidance. Orientation and navigation. Night flying presents challenges with visibility, especially regarding clouds and restricted visibility. Pilots under visual flight rules should exercise caution to avoid clouds, as the disappearance or halo around ground lights indicates restricted visibility. Ground fog, indicated by a halo or glow around lights, poses a hazard during descents through clouds, smoke, or haze. VFR night flights should be avoided if conditions are expected below visual flight rules minimums. In instrument meteorological conditions, the risk increases unless equipped for IFR flight with a prepared and filed IFR flight plan. Crossing large bodies of water at night in single-engine airplanes is potentially hazardous due to the risk of engine failure, forcing a water landing, ditching. Limited or no lighting over water can cause the horizon to blend, leading to a loss of orientation. Even on clear nights, stars reflecting on the water may appear as a continuous array of lights, making it challenging to identify the horizon. Lighted runways, buildings, or objects may cause illusions when viewed from different altitudes. At 2,000 feet, lights on an object may be seen individually, while at 5,000 feet or higher, they could appear as one solid light mass. These illusions can be acute with altitude changes, posing challenges during approaches to lighted runways. These considerations emphasize the importance of careful planning and awareness of the unique challenges associated with night flying. Pilots should be prepared to navigate and make decisions based on instruments and indicators due to limited outside visibility during nighttime operations. If you click like and subscribe and leave a comment, we will provide a coupon for a free PDF download, one of 9 ebooks. However, each individual can only download up to 1 out of 9 ebooks for free.